Have you ever been playing a game and just stopped to look at a forest? One of those incredibly dense, beautiful forests that you can just get lost in for hours? Or maybe you've seen a movie with a jungle that felt so real you could almost feel the humidity. Well, that's what we're diving into today, the magic behind digital nature. It's the art and the science of creating millions of trees without, literally melting your computer. And it all really boils down to this one simple but super powerful idea. As our source material puts it, well-crafted vegetation breathes life into a scene. And it's so true. It is the difference between a kind of sterile, empty 3D environment and a world that feels genuinely alive, a world you actually want to explore. Yeah, but here's the catch. All that life comes at a massive technical cost. Which brings us to the big question we're tackling in this explainer. How on earth do developers manage to render 1 million trees, each one with thousands and thousands of leaves, all in real time? So, to get to the bottom of this, we've got to first wrap our heads around the fundamental dilemma that every single 3D artist and game developer runs into. And that is the challenge of the beautiful but incredibly expensive digital forest. This slide really lays out the core conflict perfectly. On one hand, you've got artists and players, and we all want the same thing, realism. We want these lush, dynamic, immersive worlds. But on the other hand, you have the cold, hard limits of your hardware. See, every single leaf, every blade of grass is made of polygons. A really dense forest can mean millions of them, which can absolutely crush even a powerful graphics card. It is a constant battle between beauty and performance. So just so we're all on the same page, when we say foliage in the world of 3D graphics, we're talking about the whole shebang. Trees, grass, bushes, flowers, vines, all of it. And as the source points out, these assets are, pretty consistently, some of the most demanding things you can possibly try to render. So how do they solve this? Well, the solution doesn't start with just throwing more computing power at the problem. It actually starts with some incredibly clever artistic magic tricks. And to see how it works, let's start small. Let's build just a single digital leaf. And here is one of the oldest and honestly most brilliant tricks in the book, alpha masking. So instead of trying to model the complex, jagged shape of a leaf, an artist just starts with a super simple flat rectangle, a really low polygon plane. Then they slap a picture of a leaf on it, a texture, that has what's called an alpha mask. And all that mask does is tell the computer, hey, this part's the leaf and everything else is transparent. And boom, the result is a complex-looking leaf that uses almost no geometry. It's a total illusion and it's absolutely genius. Okay, so that illusion works great for a single leaf, right? But what about a whole forest? Well, to scale that up, you need even more tricks. And this time, they're on the engineering side of things, all designed to manage performance. Two of the big ones you'll see all the time are billboards and foliage cards. A billboard is pretty much what it sounds like. It's just a flat picture of a tree that always turns to face you. It's perfect for those trees way off in the distance on a mountain. Now, for stuff that's a bit closer, developers use foliage cards. These are basically just bunches of those alpha-masked leaves we just talked about, all clustered together to create the illusion of a full 3D branch or bush. Both are just essential tricks for faking that density without bringing your system to its knees. Right, but a forest full of trees that are just frozen in place? That doesn't feel very alive, does it? So the next big step is making the world actually breathe. And the secret sauce behind all that movement, it's often a technique called World Position Offset, or WPO for short. The easiest way to think about it is like a little command that tells the individual points of a 3D model, hey, move around a bit. By feeding that command a simple wave or some noise patterns, artists can make leaves, branches, and even whole fields of grass sway and rustle in the wind. It's a crazy efficient way to add that final, crucial layer of dynamic life to a scene. So, as you can imagine, putting all of this together takes a whole toolbox of specialized software. An artist might use a program like Blender to handcraft some really unique hero assets. But for generating thousands of different trees procedurally, the industry standard is a tool called SpeedTree. And then, once you're inside the game engine itself, like Unreal Engine, there are these amazing tools that let you literally paint all of this foliage across your entire landscape. Okay, so all these tricks we've been talking about, alpha masks, billboards, all of it, they're super clever, but they were all invented to get around a huge fundamental limitation. But here's the thing. A new technology has just shown up that is completely changing the game. We're talking about the Nanite revolution. To really get why Nanite is such a massive deal, you have to look at how things used to be done. I mean, developers were in this constant manual battle for performance. For every single tree or bush, they had to create multiple versions of it, what they call level of detail models, or LODs, and then manually swap from the high detail one to the simpler ones as you got further away. They had to rely on all these culling tricks just to hide stuff that wasn't on screen. It was a huge time-consuming amount of work. It was just this constant, painful struggle between what artists wanted to create and what the hardware could handle. Until now. This is Nanite Foliage, introduced in Unreal Engine 5. Now, the technical term is a virtualized geometry system, but let's simplify that. Think of it like a super intelligent streaming service, but for 3D models. It's so smart that it only streams and draws the microscopic detail that your eye can actually see in that specific moment. It lets you have a practically infinite amount of detail on screen, and it handles all the complexity for you automatically. So the key thing to get here is we are not talking about millions of polygons anymore. No, we're talking about billions, with a B. With Nanite, developers can create forests with the kind of detail you'd normally only see in a Hollywood movie, and it just runs smoothly. The old trade-offs are finally starting to melt away. So what does this actually mean for creating and experiencing these virtual worlds? Well, for starters, it means that game assets can have just incredible movie-quality detail even when you walk right up to them. Second, the engine takes care of all that tedious, manual, detail management stuff automatically. But most importantly, it gives artists this incredible freedom to create the worlds that are in their imagination without being held back by those old performance bottlenecks. And you know, all of this really brings us full circle, right back to the core theme of this entire process, that beautiful place where art meets efficiency. Because at the end of the day, even with mind-blowing tech like Nanite, the source material really hits on the most important point. The real skill lies in finding that balance. You know, a beautiful scene that runs terribly is just as much of a failure as a super fast scene that looks empty and barren. It's always about finding that perfect blend. And that really leaves us with a fascinating question to chew on. For decades, building a digital forest was all about compromise. But now, those technical barriers are just crumbling away. So you have to wonder, if a forest can now be infinitely detailed, what kind of new worlds are creators going to imagine next?